Okay, so let's do the chapter 1 today. So what is earth science? Introduction to earth science. So if you have, you can go through as I'm teaching. It's in your ebook, so you're going to follow the ebook. So what is this? What we learn? What is the use of this first chapter? So what we're going to learn in the first chapter, we're going to study what is the makeup of the earth. What is earth made up of? So if you want to understand the makeup of the earth, so if somebody baked a cake, if somebody gave a cake to somebody, and they want to know, hey, how did you make this cake? It's so good. What are the things you used for that? The first question you're going to ask them. Like that, so for the earth science also, for the earth's material, if you see something unique, you want to understand what is that made of. So in order to understand the earth's processes and the earth's material, you need to understand what is earth science itself. So you have to study the makeup of the earth. So we have different chapters for that. Then we are going to study what is a scientific inquiry, what is a scientific method, and how do you make these laws. You probably studied in your earlier science classes. You study what is the scientific method. Scientific method is nothing but it's a systematic way of unraveling the mysteries of this world. It's called as scientific method. It's a system. So what are the first thing? So if you see a natural phenomenon in nature, what is the first thing? Like if you see consider outside is like a darker color coming, and there is clouds are very dense, and what do you expect? Rain, right? So that's the mind. Our human mind has already gone to that idea, right? So that's the concept is already built in us. So for that, when you see a natural phenomenon in nature, what is the first thing you observe? Now, even if I take a 5-year-old or a 6-year-old kid, if I ask them to see outside and tell, hey, what's coming up outside? Do they tell it's going to rain? Yes? Yes, because when they're small, when the moment they start looking at the world, they're actually observing stuff, and they're gathering the data in their mind, and based on the pattern, they're already making up this hypothesis. And what is hypothesis? It's a tentative explanation. It's called as hypothesis, which is not yet proven yet. That is called a hypothesis. So before I go, hang on, I need to, is this, okay, I'm going to record anyway. Okay, so that is what, so once you have hypothesis, if somebody comes, if Miss Tillman, if you came up with an hypothesis, do I have to believe it? No. We live in a scientific world. Everything has to be supported by scientific evidence. So how can you prove your hypothesis? You have to test those hypotheses. So what we do to test my hypothesis? I do experiment to test my hypothesis. So that's what is called. So these are, once you do experiments, what do you get, Ms. Flores?
You get data.
You get data. Good job. You get a data. Once you got the data, you analyze the data. You correlate your data. You compare your data with your hypothesis. If your data is supporting your hypothesis, then your hypothesis was right. Then sometimes some results might be like a fluke. It might just come once. Next time they're trying to do that, it's not working. Was his hypothesis right? Sometime first time it came up results, like somehow it was lucky and he gave. Second time she was doing the same experiment, she's not getting the same results. So was his hypothesis right? No. So now what I have to do is to make it, so I have to go back again, start thinking, oh, probably this method didn't work, so I have to change this, I have to tweak this parameters, I have to change this parameters then I will see if I get the data, collect the data again and correlate my data, analyze my data, and then once your data is right, yes, my hypothesis is right. And now if Miss Flores did the experiment and Miss Tillman did the same experiment, she got the same results, I did the experiment, I got the same results, then Miss Foster did the experiment, she got the same results. Miss Edwards did the experiment, she got the same results. Mr. Brown did the experiment, he got the same results. Eventually, your hypothesis is supported by all these experiments. And eventually, when your hypothesis is supported by so many experiments, your hypothesis eventually becomes something called as a theory. And when that theory is supported by extensive work done by different researchers in different world and accumulate and supported by massive amount of data, your theory eventually becomes what?
A law.
Good job. It's a law. Your theory will become a law. So you see how a law has come? Our entire universe works on physical laws. Everything. It's a physical world. That's why physical science is study of the physical aspects of the world. We work according to physical laws. We are all laws already there. We are unraveling the mysteries of this world. And that is the figure. So you see, one fine day, somebody thought that idea came in their mind and it became a law. Likewise, you probably heard about laws, gravitational law, Newton's laws, first law, second law, third law, different laws, law of conservation of mass, right? These are, so all these laws are nothing but somebody's hypothesis once upon a time. So all this systematic, so there is a systematic way to do this study, and this can be applied, this method can be applied to any field of subject. It can be geography, it can be marine biology, it can be medical, it can be history, it can be geography, it can be literature, any mathematics, it can be any field. It is the same three important steps. What is the first important step of scientific method? First one is observation. Second one is hypothesizing. Third important step is experimentation. All these three are the important steps in scientific method, and all is done in a systematic way, and that systematic way is called as scientific method. So I'll go to the next. So we'll come back to scientific method more. Okay, so what is earth science? All these stories I'm telling is all about earth science. It's a study of earth, and earth is not just one piece, it comprises several things. So any sciences that seek to understand the earth and the neighbors in space, because if I want to understand about the earth, I also need to know about my neighboring planets. They might have some effect on us. You say, people say sometimes you hear about some meteorite is going to come and hit the earth, we are all going to die. Those kind of stuff. So to understand that thing, so we need to know. So any science that seeks to understand the earth and the neighboring in space, that is called as earth science. And earth science is not one science. Earth science includes, this is very important, and all these are quiz questions. First one, geology, study of the earth. Second one, oceanography, study of the waters around the earth, because earth is surrounded by 71% of waters. So we only live in that remaining 29%. All these countries, all these different kinds of people, all these skyscrapers and everything in every part of the world is all in the 29% of the dry land. Remaining is all covered by water. That's why it's very important to study about the oceans, the effect of oceans on the land. That's called a study of ocean. Third one is called as meteorology. What is meteorology? We have a very thick blanket of air above us. That is called as atmosphere. And the process that produce the weather. So study about the atmosphere and the processes that produces the weather. Today's weather was pretty. Coming 2 days, it might be nasty. Rainy and some people don't like rainy season. Some people don't like hot. It might be sultry. It will be too hot. Humidity is so high, right? So the heat index will be high. People get sunstroke and all. So that's why. So all this comes under meteorology, study about the atmosphere and the process which leads to the weather conditions. Then the last one is astronomy. It's very important to understand our neighbors also. So study about universe is called as astronomy. Okay, so these are the 4 sciences. First one is geology, astronomy, meteorology, and oceanography. It doesn't have to be in same order, but you remember what are what. So next one, what is science? Science is the study of the physical world. It's called as science.
Is that supposed to be changing?
Yes.
Oh, it
yes.
wasn't changing.
Okay. Science. Okay. Thank you. Science is a study of physical world. Assumes that the natural world is considered. So what is it? Science is consistent because everything is the physical world works according to the law, and it is predictable. Some of the outcomes are predictable, like some of the rain you can predict something rain. So that and what is the goal of science is to discover the patterns in nature. To unravel, to understand the nature, the physical world, we need to learn science. And to gain the knowledge from that, and then to utilize this knowledge for the betterment of mankind. Like everybody has fancy cell phones, and all the screens are so nice. Everybody wants to have those high-end cameras in that. But what makes it take those? What are the materials inside the screen? All these are some of the materials comes from the earth's crust. So some of the jewelry, the gold, platinum, and all these are. So these are how people discovered. Once upon a time, they discovered how to extract from the earth's crust diamonds. I think nobody likes diamonds, right?
They're kind of plain to me, so.
Everybody likes diamonds, whether it's a powdery form or it's a solid form. But where the diamonds come from, deepest part of the earth, diamonds. So that's all. So they are used for all these technology are used by learning science and applying for the betterment of life.
It
Science.
just interests me that diamonds are usually like where they were originally coal.
Coal.
And they were just like put under pressure to
Yeah.
like turn into diamonds.
Diamond. All
So they
coal,
were like
yeah.
this useless little rock to make this really pretty
Yeah.
expensive now.
Yeah, so diamonds are nothing but, actually if you see diamond, it's carbon. Nothing but it's carbon. And diamonds, if there is a company in England, they make diamonds out of peanut butter. So that diamonds, yeah. So diamonds under high compressed carbons. They make crystal, it becomes a crystalline and is prized for its beauty. Okay, it's less, and diamond is the hardest known substance. Diamond. Okay, next one. I go to the next slide. Okay, I just explained this. What is hypothesis? Everything I just explained. First, it's an idea to become. What is that hypothesis? It's a tentative, untested explanation. What is a theory? It's a tested, confirmed, supported hypothesis. As I told you, and it's not just one experiment. It has to be several experiments. It becomes theory. And now this, what is a scientific method? It is the method which involves gathering of the facts through observation. You observe. First thing you do is observe. Then you formulate your hypothesis. That means reasoning, tentative reasoning or tentative explanation. And the third one is you want to test your hypothesis, and that's what is to formulate theories. How do you do that? By doing experiments. Okay, to formulate theories. If your hypothesis did not match, you have to go back again from the starting and do the same thing like a flow chart. Okay, next one, scientific knowledge. So what is scientific knowledge? So these are the different parts of this scientific knowledge. Is gained through following steps, systematic. First one is again collecting the data, collecting the facts, developing a hypothesis, conducting experiments because you want to prove your hypothesis, then re-examining the hypothesis if you are accepting, modifying or rejecting. You have to do that because to match your hypothesis. And these theories that withstand, and then you'll get a theories which withstand the test of time, and then totally unexpected. Sometimes you get a results which are unexpected, totally unexpected. Those are called as serendipity. There are certain, in medical field, there are several serendipities. Okay, formation of the earth. So let's see what are the most results. So if you see, okay, now before you go further, if you are in your textbook on page 7, you can highlight what is what is geologic time? Is the span of time since the birth of the earth is called as, since the formation of the earth is called as geologic time. It's the span of time since the formation of the earth is called.
What page is it on?
Page 7. Page 7 in your textbooks.
Oh, okay. This is
Okay, yes. And also come to page 6 if you in your textbook. If you see there are natural hazards. Can you give me some can somebody can tell, even somebody is online, you can answer if you can. Can you give me some example of natural hazards?
Hurricane?
Hurricanes, good job. What else, Mr. Tillman? Can you give me one more?
tornado?
Landslides, good job. Tornadoes, good job. Can somebody give me a man-made natural hazards? Not natural, man-made hazards. Earthquake, good job. Sometimes people test nuclear bombs.
Yeah.
They causes earthquakes. Most of the times it's natural process, but sometimes it's created by humans. Then what else? Pollution.
Yeah, the oil.
What's that?
Fracking?
Yeah, fracking. That's what. By fracking also earthquake causes earthquake because you're messing with the plates on the earth. What's that?
Oil.
Oil drilling. Yes, we're going to learn that. And then you heard about pollution, right? Pollutions are also natural hazards. Not natural, man-made hazards. Water pollution, air pollution, sound pollutions, and all these are man-made. Then smog, like a lot of pollution left. If it's cold, smoke gets suspended in the atmosphere. It becomes smog. What is smog? Fog plus smoke called as smog. When if you breathe smog, you breathe solid particles which are very toxic, and you have people with those kind of places, and we have a lot of pollution. People have a lot of respiratory problems, asthma and everything. So it's very important. Then comes resources. What is a resource? There are different types of resources. Why Earth is important? Because Earth has natural resources comes from the earth. That are, some are metals. Sometimes you get non-metals. What are the other resources you get from the oil, natural product, natural gas? That's a natural resource, right? Then you also get resources. You get sand, concrete, gravel. All this comes from the earth's crust. And minerals comes from, trace minerals comes from the earth's crust. Salt comes from the earth's crust. All these are resources. There are two types of resources. One is resources which if you keep on using, they cannot replenish back. Those are called as non-renewable resources. But there are certain resources which are renewable. They can be renewed every time when you consume. One of the best example anybody can give. What is the best example of a renewable resource?
Solar.
Solar energy. Good job. It's a solar. Every day we get a fresh dose of solar radiation, right? So that's a flow. So that is called as a renewable resource. The other type of resources are non-renewable resources. Okay, I'm on page 7. If you're on textbooks, I'm on page 7, and if you're this PowerPoint also later part. So if you see how these galaxies are formed, so it starts from an atom, which is the smallest unit of a particle is called as atom. Atoms combine to form minerals. Minerals combine to form rocks. Rocks combines to become mountains. Mountains eventually becomes planets. Planets to galaxies, Milky Ways. You see how they are coming? It starts from the base is small. That's how. So these are so highlight. And so sometimes, so if I'm on page 7, scales of space and scales of time. There are certain processes which happens on the earth crust, on the earth, in a fraction of time. But there are certain processes which happens, it takes its own time. Can somebody give me an example of a process which happens in a fraction of time?
Fraction time?
Yeah, I mean short time. A fraction means not just a little bit, but short time. What are the give me some example of processes which are happening on the earth's crust.
Avalanches.
What's that?
Avalanches.
Avalanches. Yes, actually I saw one time when I went on glaciers. Luckily we didn't. We passed through that area, but they were already cordoned. But we were like researchers, and we wanted to be a little bit more curious. We went, and luckily there was an avalanche. So that's a good example. Lightning happens in fraction of second, right? See, the current voltage in our houses is 110. Can I touch that? Live wire, it's a 110 only. But the lightning which comes from the earth, from the atmosphere, from the clouds, it's several million volts of electricity. That's why lightning strike is so dangerous, because it's millions of volts of electricity. It's not 110, not 220, it's several million volts. And it comes just within fraction of a second. So lightnings are example. Then the hurricanes, tornadoes, these are short span. But there are certain processes which happens on the earth's crust which takes their own time. One of the best examples are mountain buildings, weathering and erosion. You see those, you see the sand. Where do you see sand? Much of the sand.
In deserts
And
on the beach.
on the beach or the oceans, right? Where those sand is coming there and getting accumulated. It's been coming for once millions and millions years ago. A big rocks broken down into pieces and every time they're getting withered, broken down, keep on breaking down, and then eventually become sand. So that process is not happening within our eyesight. It's happening millions of years. It's a slow process. So those are called, that's why span of time and span of space. Span of space is an atom is so small, galaxies are so big, right, compared to that. So those are, so processes can happen in short time, in a large time. So you see, now formation of the earth, how that happened, most of the researchers conclude that the earth and the other planets are formed at the essentially same time. There are different theories. People believe in different. One is called biblical theories also there, biblical approach. Okay, that's creationist. God created in 7 days. People who believe, they have their belief that. Some people don't believe that. People, they have their own belief. Some people, they are called evolutionists. They believe that earth has evolved over time. According to the evolutionaries, the people have, the planets are formed at the same time, other planets. According to this, and this theory is called, this is important quiz question, it's called as a nebular theory. So according to the nebular theory, all the planets have originated at the same time along with the earth. So what is that theory? Nebular theory says that the solar system has evolved from an enormous rotating cloud. And that rotating cloud is called as, this is again a quiz question, it's called a solar nebula. So if you see the nature of scientific inquiry, I already finished. I am on this page, what I am teaching is on page 11 in your textbook. What is nebular theory? That the earth, the sun, solar system has evolved from a rotating cloud of gases. That is called solar nebula. And how that has happened? According to them, the nebula was composed mostly of what was nebula? It's this rotating cloud of gases. And what gases was there before? There was no oxygen before. Oxygen was formed later on when great oxygenation event took place. But before that, it is the lightest. So which is if you remember, if anybody science student is there, which is the element with the lightest mass? Which is the first element in the periodic table? Ms. Tillman, you can see right in front of you.
Oh, oxygen?
Now, whose number is 1?
One.
Hydrogen. Hydrogen gas is the element with the lightest element in the entire periodic table. That's why when you fill a balloon with oxygen and a balloon with hydrogen, which one will go away into the sky?
The hydrogen.
Hydrogen goes away. Why? Because hydrogen is so light. The mass of hydrogen gas is 2, whereas the mass of oxygen is 32. That means oxygen gas is 16 times more than hydrogen gas. So that's why it's heavier. It does not go. But if you hydrogen gas escapes. That's why all the our Earth, if I throw something in the air, why it is coming down? Why it's not going up?
Because it's heavy.
Yeah, but what is pulling it down? Gravity. Good job, Mr. Tillman. It's gravity is pulling it down. But why hydrogen gas is not able to pull? It's keep on going away because our Earth gravitational force is not enough to pull that gas down the Earth. But there are certain planets who has a great Jupiter has the gravitational pull of gravity of Jupiter is so large that it can pull even the hydrogen gas. And since it's away from the Earth, it is very cold. So hydrogen gas actually exists as solid metal. Solid, it looks like a metal. It's solid hydrogen gas in the Jupiter. Because the power is so strong, it holds it down and it's so cold, so hydrogen gas becomes like a shiny metal. That's why hydrogen is, if you see the periodic table, hydrogen is placed along the metal side. Top left corner is the metals. Top right corner is the non-metals, all gases. But hydrogen is put in here because the hydrogen in solid form acts like a metal. Shiny, it looks like a shiny metal. That's why. Okay, now, so the hydrogen gas. So next one is, so what is the highlight? That nebular theory is important. So nebular theory says that the bodies of the solar system evolved from a rotating cloud, enormous rotating cloud, which is called a solar nebula. And this composed of, what is solar nebula made of? Hydrogen and helium. Those are the two lightest gases. About 5 billion years ago, the solar nebula began to contract. These rotating clouds of gases, and how that gases started. There was a big, according to this Big Bang, people who believe those Big Bang, according to Big Bang theory, one fine day, because of the energy, there was a large explosion took place, and energy is released in all directions, and they gave rise to birth of solar system, and the nebula contracted and becomes like a flattened rotating disk, and then the pull of the gravitational energy into thermal energy, it forms a disk, and that eventually gave rise to these circulating rings, center form, and that center portion, because of the gravity, it got contracted in the center, and eventually it gave rise to early sun, which is called as proto-sun. About 5 billion years ago, the nebula began to come, and it assumed a flat disk shape with the proto-sun at the center. And once this proto-sun is formed, and over the millions of years, these particles clumped together, and they collision, and these particles started colliding with each other and getting condensed, and they gave rise to different planets. First, there were 4 inner planets were formed. So what are the 4 inner planets? And these early planets are called as planetesimals. These are important. Highlight on page. Planetesimals are in page, hang on, where are the planetesimals in your It's not in this. It is called early planets are formed. They are called planetesimals. It's okay. It's not in your new book. In the old book you have that. Okay. Now comes. Oh no, it's there. It's on page. If you are on page textbook, it's on page 14. There is a term called planetesimals. That's important. So I say repeated collisions caused these masses to coalesce into larger asteroid-shaped objects. So what happened? The small molecules collide with each other, started becoming bigger and bigger, and gave rise to asteroid-shaped objects, larger, and these are called as planetesimals. And from these
What is it?
planetesimals. Okay.
Decimals.
Yeah, planetesimal. I'm going to tell the spelling. It is PLANETESIMALS. Planetesimals. These are the early planets are called. And once they gave rise to first early planets. What are the 4 first early planets? What is a planet which is very close to the sun? Mercury, then Venus, then Earth, then Mars. So remember, there are first 4 inner planets are formed. What are those? Mercury, Venus, Earth, and Mars. Then it gave rise to remaining outer planets. What are those? Those are Mercury, Venus, Earth, Jupiter, Saturn, Uranus, and Neptune. Until 80s, they also included Pluto, but now Pluto is considered as a dwarf planet. They are not considered as a real planet. So remember, there are 4 inner planets, 4 outer planets: Mercury, Venus, Earth, Mars, and then Jupiter, Saturn, Uranus, and Neptune. These are 4. Okay, according to nebular hypothesis, you see, the inner planets begin to form from metallic and rocky clumps. Larger outer planets began forming from fragments with the high percentage of ices. And why it is ices, larger percentage, outer planet? Because they are far away from the sun, right? They are very cold. That's why. But inner planets are made up of rocky and metallic fragments. That's why we see a lot of rocks on Earth. But when you go to Jupiter, Saturn, Uranus, it's mostly ice, pieces of percentage of ice, water. That's why. Okay, see, this is the picture exactly what is in your textbook also. How from a big bang, it started colliding, forming proto-sun. As a result, the rings are getting collided and coalescing and form rings. And eventually these rings gave to inner planets, sun, and after sun is formed, they gave rise to 4 inner planets and 4 outer planets. And this process where it started from rotating cloud, of that this theory is called as nebular